In this video, I'll be explaining question 7 of homework 9. So the question states that we need to show that the random telegraph signal is a strict sense stationary process. So we'll assume yt equals to axt to be a random telegraph signal, and we know that for a random telegraph signal, probability of a equals to -1 equals to probability of a equals to 1 equals to half. And here xt is a random variable which is also independent. Now we know that probability of y tn equals to 1, ytn minus 1 equals to 1 up till yt1 equals to 1 can be written as probability of ytn equals to 1 given all the other probabilities, which is ytn minus 1 equals to 1 up till yt1 equals to 1 times this probability, whole probability again, which is probability of ytn minus 1 equals to 1, ytn minus 2 equals to 1 up till yt1 equals to 1. And so we can keep on splitting this term. So here we are splitting the term tn minus 1, so this term will remain as it is, the first term. The second term will be basically probability of y tn minus 1 equals to 1 given probability of y tn minus 2 equals to 1 up till yt1 equals to 1 times the probability of this whole term again, this term again, which is ytn minus 2 equals to 1 and ytn minus 3 equals to 1 up till yt1 equals to 1. So yeah, we can keep on splitting this term. And we also know that from the question that we need to show that probability of y tn equals to yn, ytn minus 1 equals to yn minus 1. Basically this whole term should be equal to probability of y tn plus epsilon equals to yn, tn minus 1 plus epsilon equals to tn minus 1 up till y of t1 plus epsilon equals to y1. And this should be true for any value of n and any t1 t2 up till tn and any value of epsilon. So yeah, we are just rewriting this previous term, this term, and so yeah, ytn equals to 1, ytn minus 1 equals to 1 up till yt1 equals to 1 can be written in this form, which is we are basically using that this is a Markov process. So the like from the Markov process we know that the probability of any future event is independent of past events given the present event. So tn will be independent of it will only depend on tn minus 1. So yeah, we can write the previous, from the previous term we can write it as p of probability of ytn equals to 1 given ytn minus 1 equals to 1. So it will just tn will depend on it will not depend on any other values, which is tn minus 2 and so on. Similarly, the second term will be p probability of y tn minus 1 equals to 1 given y tn minus 2 equals to 1 and so on up till probability of yt1 equals to 1. And yeah, so this is the function of tn and tn minus 1. And yeah, so and we can clearly see that it is independent of n. So we can write each of the term in the following form. So we can write like probability of y tn equals to 1, given y tn minus 1 equals to 1 in the form of exponential and cosine values. So yeah, we can write it in this form. And so we can also see that in each term in equation 2, which is basically uh, yeah, this equation, uh, it can be written in the form of the equation 3, which is this equation. So we can replace each term in this form. And now if we try to replace tn with tn plus epsilon, we see that epsilon will get cancelled in all of these terms. So the final equation that will be is that uh, probability of y tn equals to yn tn by tn minus 1 equals to y n minus 2 up till y t1 equals to y1 can be written as prob is basically equal to probability of y tn plus epsilon equals to yn, y tn minus 1 plus epsilon equals to yn minus 1, and so on up till y tn plus epsilon equals to y1. So this is what we had to prove and so yeah, we can say that this is a strict sense stationary process. And yeah, that is what we have to prove for uh, the random telegraph signal.